Alright, the next problem I'm going to do is a half-life problem. You'll see lots of half-life problems over the next week or so. This is number 3 on the worksheet about exponential growth and decay. It says that let's talk about radium. Radioactive substance. It says that it has a half-life of 15 years. I'll write that. Um, 10 grams present, so 10 grams to start. Time equal to 0, 10 grams. And it wants to know how much is there, how much will be radioactive in 50 years. So, P of 50. Alright, so, let me go to blue. Once again, like number 2, I'm working the poked model. P of T is equal to P naught E to the KT. First thing I need to do is solve for K right here. If I can get K, actually no, even before I do that, sorry. Eraser. This line right here tells me that at time equals 0 we got 10 grams. That's the initial population, or what we call the initial population, the initial amount. So that goes right here. So I know that P of T is equal to 10 e to the KT. So next thing I need to do is find K. This time I'm actually right about that. So I need to find K. Scroll down. I'm actually I won't scroll down yet. I need to use this information about half-life right here. Sorry, that half-life is 1590 years, not 15 years, so 1,590 years. All kinds of screw-ups here, huh? Anyway, what that tells me is that half of the radioactive substance will be gone after that many years. So if P models the amount of P of T models the amount of radioactive substance over time, and I start with 10, then half of that gives me 5. So this right here tells me that P of 1590 is equal to 5. So I'm going to plug that in here. This is my T value, that's my P value. So 5 equals 10 e to the k times 1590. Scroll down. Solve for k. Divide by 10. I get 0.5 equals e to the 1590 k. I switched the order of those two, but that's okay because it's multiplication. Now, how do we get rid of e to the? Well, it's an exponential function, e to the whatever, blah, 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 blah. If I want to get to the whatever, blah, 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 then I need to do the opposite of an exponential function. Remember, ln is log base e. So when I take log base e of, for example, e to the 16x plus 5, that would give me the log base e and the e to the would cancel. Because they're inverses, it's like squaring and square rooting. It would give me 16x plus 5. So, we don't ever write log base e, we just write ln. I'm going to take the ln of both sides here. You should see what happens. I'll go back to red. ln of 0.5 equals ln of e to the 1590k. Just like I said before, ln, which is log base e, and e to the cancel, so that gives me these guys boost each other out, boink, and just leave me with what's up top in the exponential function. So I get ln of 0.5 equals 1590 times k. This should be easy to solve for you. I simply divide by 1590 on both sides, which gives me k equals ln of 0.5 over 1590, which it's important, so I'll do it in blue. K is equal to, the way the calculator writes it, depending on the mode of your calculator, is negative 4.359 with a capital E and then a negative 4. You should know that this is scientific notation, that it's that number times 10 to the negative 4, and to write it in non-scientific notation, I just move the decimal 1, 2, 3, 4 points, which leaves me with 3 zeros. So I get k equal to 3 zeros after the decimal place. 0.123, and then 4, 3. I could write 59, but to keep 3 decimals of accuracy, I'm going to round the 9 up to a 6. But I, and you should do this too, would just store this number right here on my calculator. A good letter for that might be K. Anyway, that tells me, almost done, P of T is, I'll go back up so you know where we are. Remember, this step right here, I wanted, maybe I'll use the fancy pen. This step, I don't like that. There's no undo button. Sorry. I guess I'll just go like this. Okay, that step up there, I wanted to solve K. I know this is a lot of work. All this red down here was solving for K. So I'm going to plug that K value into the equation. Oh, what did I not do? There's a negative sign there. So that's a negative decimal. P of T is 10 e to the negative 0.123 decimals, and then 436 t. P of 50 is what we're looking for. I could go up to the top, but I'm not going to. It asks for how much is present after 50, so that's 50 years, so that means my time is 50. Plug it in your calculator. Using that stored variable, you should get 9.784 grams. So if you remember back, the original amount was 10, half-life of 1590. That means that it's going to take that many years for it to go away. It makes sense. I want you all to think about it. Does it make sense? Does it make sense? Does it make sense? Yes, it makes sense because we started with 10. It was decaying. Less and less is going to be there. The half-life is like 1,500 years, 1,600 years. So after 50 years, not really that much is going to be gone. So this answer makes sense contextually, and you should be able to tell when your answers make sense contextually. If you got a number like, I don't know, a number bigger than 10, that wouldn't make any sense at all. If you got a number less than 0, that wouldn't make any sense at all. And actually, if you got anything close to 5 or below, it wouldn't make sense at all because that 1590 is nowhere near 50 years. Anyway, that's all. Still waiting for my dog to make some noise.